Good morning, my dear students. Today we are going to learn about the derivations of precision angular motions. Okay, dear? Precision of angular motion. So let us consider a disc is mounted on axis. The disc is or rotor is mounted on axis. So this axis is known as axis of spin. What we can say here? Axis of spin. Okay. And the vertical direction, the y, we can say as axis of precision. What we can say here? Axis of precision. And this z direction we can say as reactive gyroscopic couple. The z direction we call as reactive gyroscopic couple. Okay, here, and this line we can say as it is a process from the origin point. Is it right? So this one we can say as new axis of spin. Okay, and here this one we can say as active gyroscopic couple. And this point, what we can say? We can say as disc or motor or shaft, we can say. Let us consider a disc is mounted. The disc is mounted on axis. So what we can say here? Axis of spin. If this disc is rotated in anti-clockwise direction. How it is anti-clockwise direction? Let us see. If your observer is observed from the front view, this is observer. Okay, dear, observe from the naked eyes. Observer is observed to this disc. This disc is rotated in which direction, dear? The disc is rotated in anti-clockwise direction, and this one is can show as angular momentum. Okay, dear, so it is rotated in which direction, dear? It is rotated in anti-clockwise direction. Okay, then if this disc is rotated in the anti-clockwise direction, at that time they move from initial place to the final place. Is it right? So this disc is little bit changing from initial position to the final position. The change of angle, the small change of angle we can say as delta theta. What we can say? Delta theta. If this disc is rotating, it will take some amount of time. So what we can say? The change of time. What we can say, dear? The change of time from axis of spin to the new axis of spin, they are rotating this disc. Is it right? Then, so first thing is, let us consider a disc is A disc is, where it is mounted here? It is mounted on, a disc is is mounted on whom dear? On the axis as shown in a figure. Okay dear, if the disc or rotor or rotor, if the disc is rotating in clockwise direction on any axis, okay, if the same disc if rotate in the vertical direction, this axis what we can say here? We can say as axis of skin. What about this one? Axis of precision. But this disc is rotated in which direction? In the horizontal direction. So this vector, what we can say? This vector O to X we can say as axis of spin. Okay, the disc is revolving about an axis. Okay, the disc is revolving about an axis. So what we can say here? Already as told you, is known as axis of spin. Okay dear, axis of spin. Let us consider, if the disc is rotating, the initial angular velocity of the disc, what will be there? Omega. Why it is omega? Because this disc is rotating in a circular path. Is it right? For that reason we are using the angular velocity. Is it right? Let us consider a disc of initial angular velocity is omega. The disc of initial angular velocity. So what we can say here? Initial angular velocity is omega. It represent by the vector. Which direction here? By OX. Is represented by the vector OX. Okay, and if this disc is rotate from initial state to the final state, is it right? At that time the change of angle as well as little bit change of time. Is it right? Then after that, if you observer is observed to the disc is rotate in which direction dear? They rotate in anti-clockwise direction. When the observer observe to the disc, then disc is rotate in which direction dear? They rotating in anti-clockwise direction. Then disc is rotating in anti-clockwise direction. Okay, direction. After that, then the disc, if the disc is spinning about the new axis, that what will happen? This disc will move on new axis. So what will happen here? It will change of angular velocity. How much will change? It will change a little bit angular velocity. So what we can say? This one we can say as initial velocity plus change of how much? Change of angular velocity. Initial angular velocity along with how much change from axis of spin to the new axis of spin. So we have to represent by omega plus delta omega. Okay dear. Okay, after that, if it is moving from axis of spin to the new axis of spin, at that time the change of angle as well as change of time. Is it right? Then let us consider, let the disk is spinning about new axis of spin, the angular velocity, the final angular velocity is omega plus delta omega, represent by the vector, that is the most important, the represent by the vector OX dash, represented by the vector OX dash. Is it right? That at that time, at change of angle is delta theta, as well as the change of angle is delta theta, as well as with respect to given interval of time delta theta, as shown in a figure. Okay here, as shown in a figure. Here, okay dear, so we are finding by the right hand screw rule. Okay, finding by the right hand screw rule. So let us again, I will explain. Let us consider that this is mounted on axis, we can say as axis of spin. What we can say? Axis of spin. The disk is rotating from initial velocity to the final velocity. Okay, the disk is mounted on axis. It is represented by the vector is OX. The initial angular velocity of the disk is omega. Initial angular velocity of disk is omega, and the final angular velocity of the disk is omega plus delta omega. Okay, with the change of angle, with the change of time. Is it right? It is represented by right hand screw rules. If you observe by the right hand screw rule, then we can observe that the disk is rotated in the anti-clockwise direction when it is observed from the front view. Is it right? Let us. Then this angular acceleration is resolved into two components. Angular acceleration is resolved into two components. One is parallel to OX and another component is perpendicular to OX. I will represent by the vector diagram. Let's see. Shall I rub this one? Okay. Let us consider the same figure I am represented by the vector diagram. This is O is the origin point and it is lies in which direction? X direction. Okay, and then the angular velocity of this disk. Okay dear, the initial angular velocity of this disk is what we can say here, it is omega. Okay, then it is change of new axis of spin. So what we can say, this one we can say as x dash. What we can say here, x dash. This 0 to x dash we can say as new axis of spin, and this O to x we can say as only axis of spin. Is it right? Then after that we need to join here. The one is axis is parallel OX, another one is perpendicular to the RX dash. Okay dear, let us consider the component of angular acceleration in the direction of OX. The component of angular acceleration. The component of angular acceleration in the direction of OX. Okay dear, in the direction of OX. Let us see, if this disk is rotated here anti-clockwise direction, what about in the new axis? They rotate in the same direction only. Is it right? This disk is appear on the new axis of spin, again it rotate in which direction here? In anti-clockwise direction. What about this x to x dash? Again it will rotate in the anti-clockwise direction. Is it right? Then let us see, here we can say as the change of new axis of spin is omega plus delta omega, and this one what we can say here, we can say as new axis of spin. New axis of spin. Let us consider the component of acceleration in the direction of OX. First thing is we need to find out the acceleration. Alpha t equal to, what is the acceleration formula? Acceleration is the rate of change of velocity with respect to time, we can say as acceleration. But here we are telling about the component of acceleration in the direction of OX we need to find. So first condition is it is resolved in parallel. Parallel is which one is there? X R. So we have to change the change of velocity. How much velocity change? X into R. First we have to consider X R. So change of time means delta t. So what we have to represent here? The change of how much? Small time is delta t. Okay dear, again please concentrate over here. First is O, another one is X, another here is R. Is it right? We are talking about XR. XR means we have to observe from where? From origin point. You have to consider from O to R. Final position OR minus OX by change of time is delta t. Okay dear. Then O to R means total how much is there? OX dash. What we can say here? OX dash. Here OX dash minus OX by delta t. OX dash, how much is change? Let us see over. That is the most important here. First is horizontal we are talking. Horizontal means it is lies in which one here? They are making here angle theta. Here delta theta. Is it right? Then this one, what we can say? Delta theta omega plus delta omega. Total we are considering up to here. Which one? Up to X dash. Okay dear. Then Horizontal means it is resolved cos theta, and here vertical sin theta. This is perpendicular and this is parallel. Okay, but we are talking about the component of acceleration in the direction of OS. It is parallel. Is it right? Parallel means OX dash. OX dash is how much is there? First is omega plus delta omega. If it is change, see over here, if it is change, means what will happen here? It will making the angle of which one here? It is making the angle of cos. Here what is the change of angle? Delta theta. Any confusion up to here? No confusion. Minus, as it is OX. OX what we can say here? OX we can say as initial angular velocity. So what we have to represent here? Only omega, that's it. By change of time is delta t. Okay dear, I am rubbing this one here. After that you need to multiply omega into cos delta theta alpha t equal to omega into cos delta theta plus delta omega into cos delta theta minus omega by change of time is how much is there? Delta t. Okay dear, then we know very well the cos delta theta means how much angle change? The small angle change. The small angle nothing but it will be considered as negligible also. So instead of cos delta theta we have to represent as cos delta theta is equal to 1. We can represent. Okay dear, then alpha t means angular acceleration equal to omega into 1 plus delta omega into 1 minus omega by delta t. Okay, then again you need to multiply omega plus delta omega minus omega by delta t. This omega and omega is cancelled. The remaining term is delta omega by delta t. That is the value of alpha t. Again see over here, up to here. Again we need to apply the limits. What we have to do here? Applying limits. We are applying the limit. So alpha t equal to, so what we can say? Limit delta t is equal, delta t is equal to 0, delta omega by delta t equal to d omega by dt. We can say this is the value of angular velocity in the x direction. So it is considered as equation number 1. What we can say here? Equation number 1. Again, next one we are going to learn. Please take the snapshot here. Okay. Next one we are going to discuss. Next one is component of angular acceleration in the direction of OX which is perpendicular, okay, in the direction sorry, which is perpendicular to OX, okay dear, perpendicular to OX. Again we need to draw the figure. First is here OX, another one here, which one dear? That one we can say as X dash, and this one how it is moving? It is rotated in the which direction? In anti-clockwise direction. Here also anti-clockwise direction. We have to represent omega plus delta omega. Initial velocity of the disk is omega, okay, and here this one what we can say? R, okay, we can say as R here. This is R, okay dear. So we are discussing about the component of angular acceleration in the directions which is perpendicular to OX. How to find? Let us see. Alpha C is equal to the change of which one is the perpendicular? RX dash. How is it? It should be perpendicular. RX dash. Again we are discussing about acceleration. What is the formula? The rate of change of velocity with respect to time. The same formula we are using here. Don't be confused. Okay. Rx dash by change of time. How much? The change of time is delta t. Same procedure. Rx dash. So what we can say here? Rx dash we can say as omega plus delta omega. Omega plus delta omega. I told you they resolve in which direction? One is cos delta theta, vertical means in perpendicular sin delta theta. We have to represent, we are moving which direction? Perpendicular to whom? To the OX. Which one what we can say? Perpendicular to OX is would here sin delta theta. We have to represent here sin delta theta by delta t. Again we need to multiply this term omega into sin delta theta plus delta omega into sin delta theta by delta t. Okay here again the sin delta theta, delta how much it changes? If we apply the sum amount of external force on this component, it will change its position from axis of spin to the new axis of spin. Is it right? How much changes? The little bit changes. So this means that the sin theta value where we can consider as 1 only. Okay, let us consider sin delta theta is equal to how much angle is it changes here? Small angle. How much? Delta theta is changes. So we can represent the vertical direction how much? Delta theta. We can represent over here. Okay dear. Then omega into wherever the sin delta theta will be there, you have to represent as delta theta. Okay. Delta theta plus delta omega into delta theta by delta t. Okay dear. Again next thing is what happened. If you observe here delta omega, the change of means it should be small changes from here to here. How much changes? The small changes. What will the change of angular velocity, small change of angular velocity as well as small change of angle. So the both are, how is it? It is a smaller one. If it is a smaller one be there, then we need to neglect or it will be considered as 0 only. Okay, here we are considering as 0. Then we are representing here the alpha c equal to omega into delta theta plus, by delta t, we can say. Then again, if we apply the limit, then what will happen here? Applying limit delta t into 0. So angular acceleration equal to omega, apply the limit here, limit delta t is to 0, delta theta by delta t. So we can represent as omega into d theta by dt. So d theta by dt, what we can say? This one we can say as angular velocity. क्या बोलते हैं dear? So we can say as angular velocity. So see over here, if we apply this some amount of force on this disc, the disc is rotating. Okay, how much? The small angle it changes, meanwhile small delta will changes. So this one we can say delta theta by delta t, we can say as angular velocity, or angular velocity sometime we can say as what we can say? Angular of precision. What we can say? Angular velocity of precision. Wherever delta t by delta t will be there, you have to represent as omega p. Okay, then alpha c is equal to omega into omega p. This omega p, what we can say? Velocity of precision. What we can say here? Omega p we can say as velocity of precision, or angular velocity of precision. Angular velocity of precision. Okay dear, then that is our conclusion. After that, again we need to find out this one. What we can say? This equation, it is considered as equation number 2. Here again adding equation 1 and 2. So what we can say? Total angular acceleration equal to angle of acceleration in the OX direction or in the parallel direction. So what we can say? Alpha t plus alpha c. Alpha t value how much is there here? dw or d omega by dt plus alpha c value how much is there? Alpha value is omega into omega p. Is it right? So today this derivation is completed. So next onwards we are going to learn about gyroscopic couple derivations. Okay dear, thank you.